Hello and welcome to the first topic in Everyday Physics for Teachers. This topic is going to look at how does a speed camera work.
In this topic, we're going to be considering how does a speed camera work. In order to understand how a speed camera works, you're going to need to understand waves. So we'll be starting by looking at waves. We'll be considering longitudinal and transverse waves, and we'll be looking at what happens when a wave hits a boundary. Sometimes it's reflected and sometimes it's transmitted. Now, speed cameras use radar to detect your speed. So what a speed camera actually does is it sends out radar, which is radio wavelength waves. They have a wavelength of approximately 3 centimeters. These are reflected off your car and sent back to the speed camera. The speed camera can look at the frequency of these reflected waves, and from this it can work out how fast your car is going. So in order to understand how the movement of your car causes a frequency shift in the reflected wave, we're going to be looking at the Doppler effect. The Doppler effect also explains why the pitch of an ambulance changes as the ambulance passes you. After this, we're going to be looking at relative velocities so that we can describe what happens if a police car gives chase to you. You'll be able to work out the relative velocity between you and the police car, but please don't try that part at home. After this, we're going to consider ultrasounds. So ultrasounds work off a completely different type of wave. Ultrasounds are a type of sound wave, whereas the radar used in speed cameras is a radio wave, which is a type of electromagnetic wave like light. However, the physics involved in reflection and things like that is exactly the same. So we can use the same physics to describe what happens in an ultrasound scan. So I hope you enjoy this topic and I hope that you learn a lot from it.